Hello dear students, everybody, good evening. This is Basheer, math faculty from Infinity Learn by Sri Chaitanya. How are you dear students? Hope you are all doing good preparation for JEE. The dates are coming very soon. It is almost June 20th you are going to write the exam, but still we are left with 20 days, which is a good number of time, right? Right dear students, I mean to say, here in this series we have been discussing calculus part. We have started and we have discussed limits, continuity cum differentiability, methods of differentiation, right. You can also find those videos details in the description. You can please watch those even, right. So this week I am going to do 3 videos on applications of derivative. So today's going to be applications of derivative 1. Hi India, hi. So nice name, yeah, nice, I love it, right. Yeah, so in other 2 will be on maxima, minima and mean value theorems, followed by the other applications like tangent and normal even, right. Yeah, dear students. So I think you are all ready to attend the session. Dear students, here I am going to highlight a few important points, followed by certain important models of PYQ, previous year questions, going to highlight, right. As I myself, and you see here monotonicity, applications of derivatives 1. Okay. Yeah, before that, all of you, please don't forget to subscribe to our channel Infinity Learn JEE, where you can find n number of videos, and not only videos, you can have fun material, learning material. Yeah, hi Umesh, hi, how are you? Fine. We are going to catch at 6:20 in the class, but very happy to see you here, Umesh. Yeah, right. In applications of derivative, fine. So subscribe here, then monotonicity, right. So in this monotonicity, I can say precisely 2 or 3 points are enough to handle the problems. Point number 1, in monotonicity we generally discuss about increasing and decreasing nature of a function, right. Increasing and decreasing nature in the sense, you know, let me go to the result part directly. A function f of x is said to be increasing in an interval where its derivative f dash x is greater than or equal to 0 in an interval. If the first derivative is greater than or equal to 0, we can say that the function is increasing in the interval a to b. Of course, derivative equal to 0 should be at discrete set of points. Set need not be finite, but it may be infinite, but discrete set of points, right. In the same way, a function f of x is said to be decreasing in an interval if f dash x is less than or equal to 0, where derivative becomes 0 will happen at discrete set of points, right. Point number 3, when can I say a function is strictly increasing? In the sense, you see, at a particular point a function f dash of a, derivative at a, if it is greater than 0, we say that the function is strictly increasing or increasing, monotonically increasing, all the 3 are the same at a particular point. Yeah. In the same way, I can say 4th point, at a particular point if f dash a is negative, right, there we say that the function is decreasing at a, right, fine. If the function is either increasing or decreasing, we can say monotonic. Now there is another important point, suppose at a function is not differentiable, can't we talk about the monotonic nature of the function? Yes, we can talk just by observing the graph, that's it. So with these 4 or 5 points we can enter the problems, friends. Those who didn't prepare so far about monotonicity, don't worry, I am here to help you. If you follow these a couple of problems what I am going to discuss, it is enough, you can handle most of the problems, right dear students. Shall we start the problems? Okay, Umesh, ready? Chalo. Yeah. The first question dear students, you see a function f of x is given, he said it is increasing in which interval of x he is asking, right. Question number 1. So, this is model 1 friends, he will give a function, he will ask us to find and what domain of x or what values of x the function is increasing. Whenever you come across the word increasing or decreasing, go with first derivative. What is first derivative dear students? Here you see, just find f dash x, okay. It is like first function multiplied by second function, so you can say u derivative of v kind of you can do, or else yeah, you can also multiply x power 2 by 3 inside and you can check, that is also fine, your wish. So, suppose if I take u, derivative of v is going to be 2 by 3 into x power minus 1 by 3 plus v, derivative of u is going to be 3. This is the derivative friends. Now, you try to simplify this. I can say you can just you write x power 1 by 3 2 into 3x minus 7 plus 9 into x by 3x power 1 by 3 will happen, which is nothing but dear students, you can say this is 15x minus 14 by 3 into x power 1 by 3. I want this f dash x must be greater than 0 because I want increasing nature. You see x power 1 by 3 in the sense, if x is positive, x power 1 by 3 is positive, if x is negative, x power 1 by 3 is negative. So, suppose the case x is positive, in that case this must be positive, x must be greater than 14 by 15. So, when x is positive, 14 by 15 is one possibility, and when x is negative, this must be negative, x less than I can say x is negative means x less than 14 by 15 means x is minus infinity to 0. So, friends, this could be x negative, numerator negative, denominator negative. So, the division is positive. If x is positive, it must be greater than 14 by 15. You can comfortably go with option A, right dear students. Simple. If at all you want to find the interval at which the function f of x is increasing, what should we do? Simply take the derivative and see where it is positive, that is all. If you want decreasing in the same problem, simply apply first derivative less than 0, that is it. Clear dear students? I can say the model 1 is covered. In this model you can cover n number of problems, right? Fine, okay. Now, let us take up the second question. You see this dear students? What is this? F of x is given as x into cos inverse of minus sin mod x when x belongs to minus pi by 2 to pi by 2. Then which of the following is true, where the function is increasing, decreasing at some points and intervals are given, mostly 0 to pi by 2, minus pi by 2 to 0. What to do dear students here? Fine. The first thing is, what I suggest is, I think we can further simplify this particular function. How to simplify friends? You just see, this is x into cos inverse of x, you can write pi by 2 minus sin inverse, pi by 2 minus sin inverse of, I can write minus sin mod x, but sin inverse of minus x is minus sin inverse x. So, I can write plus sin of mod x, I can write dear friends. But x belongs to minus pi by 2 to pi by 2. So, mod x belongs to 0 to pi by 2. You know the nature of the function sin inverse of sin x. In first quadrant it is x itself. So, this is going to be dear friends x into pi by 2 plus mod x. That is it. Which is nothing but friends. So, almost we have simplified, right. So, you can write here f of x is nothing but friends pi x by 2 plus x mod x, x mod x. The function is clear. Now, the case of x positive, x negative, when x positive it is pi by 2 into x plus x square, when x negative pi by 2 into x minus x square when x is negative. So, this is enough dear friends to answer the question. He is asking the first derivative is increasing, our first derivative, you see f dash is increasing, f dash is decreasing. If at all you want to f dash nature, find its derivative, that is second derivative. You just see in this case what is the derivative friends? First derivative is pi by 2 plus 2x, second derivative is 2. Here second derivative is minus 2. F double dash positive means f dash is increasing. In this case, second derivative negative means f dash is decreasing in this case. That means minus pi by 2 to 0, the function is decreasing, and 0 to pi by 2, f dash is increasing. Option D is the right answer. Here to answer this particular question, what you require? Point number 1, this is inverse trigonometric simplification. Step 1, half of the problem is done. Then second, what you need to know is f dash increasing means you need to check with f double dash. So, I simplified the function, I found the second derivative. Second derivative positive means in this case f dash increasing, second derivative negative means f dash decreasing. That is all. Clear, right? Fine. Almost I can say even this problem is also going to belong to the previous model itself. He will give a function, he will ask us the interval where the function is increasing or decreasing. Of course, rather asking about f, he asked f dash, right? Fine. The next friends, you see this question, what is given? F of x function is given e power x minus x, g of x function is given x square minus x. Then the set of all real numbers where this new function h of x, which is f circle g of x, is increasing. He did not form f circle g, if necessary we can form. The point is f circle g increasing, very easier. If you see that phrase in the exam, it is very easy. That means its derivative must be positive. So, f circle g is nothing but friends f of g of x functions derivative you consider, which is going to be f dash of g of x into g dash x. That is all. Can you just find f dash of g of x? F dash x is e power x minus 1, that means e power g of x, that is x square minus x minus 1 multiplied by g dash x is 2x minus 1, right friends. Now, I want this product to be positive. Fine. So, case 1, suppose x greater than 1 by 2, this case. So, second factor is positive, so this factor should also be positive. This is positive when x square minus x is greater than 0, that is x into x minus 1 greater than 0. That means x less than 0 or x greater than 1. What is the common solution dear friends? X greater than 0, x greater than 1 by 2 case, this is the solution set. So, x greater than 1 should be taken. X greater than 1 is possible in these two options. You can simply remove these two, either this or this is the answer. Now, case 2 you can take here itself, the case where x less than 1 by 2. If x is less than 1 by 2, this is negative, so this must be negative, here less than comes, if less than 0 means x belongs to 0 to 1, x negative, you see x less than 1 by 2, but x belongs to 0 to 1 means 0 to 1 by 2 comes, so option B is the right answer. You see, as far as possible you try to avoid the calculation, with a couple of steps you can close the problem. You see, maybe calculation little big, but working, I mean logic is very simple. A function is increasing means derivative, first derivative must be positive. Same thing I have done, but of course derivative of a composite function you must know. Clear? That is the thing, dear students. The next one, yeah, you see this question, a function is a kind of bit different question, defined from r minus of 1 minus 1 to a, codomain is a, defined by this function x square by 1 minus x square is surjective. Okay. Then a is equal to, he is asking about a is equal to, fine. How to find a, friends? This is quadratic by quadratic model. You can go equal to y logic, or else you can also do, of course derivative help also we can take. I can also say, dear students, yeah, can't I find its range directly, because since the function is surjective, its range is nothing but codomain. So, capital A is nothing but range of this function. Alright, let me redefine this function like, you see, x square minus 1 by 1 minus x square plus 1 you write. So, x square minus 1 by this, when you separate, minus 1 plus 1 by 1 minus x square, which is going to be, friends, 1 by 1 minus x square minus 1. This is the function. Now, how to find the range of this? This is not a big deal, you can easily find. You can start from, you know, 0 less than or equal to x square less than infinity. You want minus x square, so you can write like, you see, 0 greater than or equal to minus x square greater than minus infinity. I am starting from here and add 1 on both sides, you will get 1 greater than or equal to 1 minus x square greater than minus infinity. Now, I have to take the reciprocal, friends. So, reciprocal, while taking reciprocal, if it is completely positive or completely negative, you can directly take. Otherwise, you need to break into two cases, dear friends. Do remember, split this into two cases. Let me write here case 1, 0 less than 1 minus x square less than or equal to 1. Now, take the reciprocal. This is going to be infinity greater than 1 by 1 minus x square greater than or equal to 1. Now, you write minus 1 to the function, infinity greater than 1 by 1 minus x square minus 1 greater than or equal to 0. So, the range is going to be, friends, I can say this is 1 to, I can say 0 to infinity will come. This is one part. The second part you can take 1 minus x square minus infinity less than 1 minus x square less than 0. You take the reciprocal, 0 greater than 1 by 1 minus x square greater than minus infinity. Now, you write minus 1 greater than 1 by 1 minus x square minus 1 greater than minus infinity. So, I can say minus infinity to minus 1. Second part is, I can say 0 to infinity I got. So, what part is not there in the solution? You see, you can go with from the range, I can remove r minus, I can take minus 1 to 0. So, here minus 1 you have to remove, here 0 is included, 0 is closed. So, you have to remove open 0. So, option C is the right answer, friends. The only thing is you must be good at solving algebraic inequations, that is all. So, that is definitely required here, along with just one simple point, increasing function first derivative greater than 0, decreasing function first derivative less than 0. Apart from these two, definitely you require how to solve inequations, how to handle inequations. You see, indirectly the functions concept like surjection is included into derivative. So, you can find the range in this way, right dear students. Next, yeah, you see this question, a function f from 0 to 2 is a twice differentiable function such that second derivative positive. Already I have told dear students, second derivative positive in the sense first derivative is increasing function, do remember, right. This is very important phrase. You see, this logic we have seen now itself in 2-3 problems. Second derivative positive means first derivative is increasing function. Fine, phi of x is a function given like f of x plus f of 2 minus x. I want to know where phi of x is increasing, decreasing. Okay, let us focus on increasing nature. So, phi dash x you just take friends, phi dash x is f of x, of course f dash x plus f dash of 2 minus x into minus 1, this is phi dash x. If you want where phi is increasing, phi dash x must be greater than 0, right. So, that means you can say f dash x minus f dash of 2 minus x must be greater than 0. So, f dash x is greater than f dash of 2 minus x, but from this data we know that f dash is increasing. So, if this should happen, you must say x greater than 2 minus x. So, 2x is greater than 2, so I can say x greater than 1, yes. So, if x is greater than 1, phi dash x is going to be positive. So, phi is increasing when greater than 1, but anyhow domain is only up to 2. So, 1 to 2 it is going to be increasing. So, increasing in 1 to 2 is present here. Obviously, decreasing means less than 0, same story runs with less than symbol. So, x less than 1, 0 to 1 it is decreasing, it is the perfect function, perfect option, right dear students, clear, okay, right. In the same way, next question friends, you see this is another question where the function f of x is given as a cubic polynomial for some a, increasing in the interval 0 to 1 and decreasing in the interval 1 to 5, then the root of this particular equation. To find the root of this equation friends, what you need to know is you must know f of x. F of x is known when a is known. Let me give you the logic here, simple, it is a polynomial, you see, yeah, you can draw its graph here. F of 0 is 7 here, because when you put 0 it is 7. You see, increasing decreasing nature has changed at 1, and 0 to 1 the function is increasing, and 1 to 5 the function is decreasing. It is a polynomial, so smooth curve. So, undoubtedly at 1 the function changed its direction. So, first derivative at 1 it must be 0, that is f dash of 1 must be 0. So, friends, what is f dash of x? You can see 3x square minus 3 into a minus 2 into 2x plus 3a is f dash of x. So, f dash of 1 is 0 means you can just see, put x is equal to 1, 3 minus 6 into a minus 2 plus 3a must be 0. So, finally, from this you will get a value is 5. Once a is 5, if you substitute a, you can find this function f of x minus 14. You can find it like x minus 1 whole square into x minus 7 by x minus 1 whole square equal to 0 is going to be the function. So, friends, the other root of this is going to be x is equal to 7. That is all. You see the language of calculus, the sum function is given, polynomial, a smooth curve, differentiable curve, continuous curve, it is increasing from 0 to 1, after 1 it is decreasing, means 1 to 5, definitely the curve has taken some local maxima. So, f dash of 1 must be 0, dear students. Okay? Fine, next. Yeah, you see this question, let f be any function continuous on closed AB and twice differentiable on open AB. It seems to be like mean value theorem problem, right? Fine. And for all x belongs to AB, this is f dash x, friends. F dash x greater than 0 and f double dash x less than 0. Then for any C belongs to open AB, this value is greater than, he is asking. Mains question. If you do not get proper idea, undoubtedly it is a time taking question, but C is some number in A comma B. So, C, suppose whatever C he is expecting, let us break the interval into two parts. I can say A to C is one interval, C to B is other interval. Let me apply Lagrange's mean value theorem. Since it satisfies both the conditions of Lagrange's mean value theorem, can I write here f of C minus f of A by C minus A. There exists some alpha belongs to open AC, open AC, such that this is going to be f dash of alpha. In the same way, f is also continuous on closed C to B and differentiable on open C to B. So, there exists some beta belongs to open C to B, such that f of B minus f of C by B minus C is f dash of beta, right. Undoubtedly, in the interval A to B, friends, A to B, I have chosen somewhere C here, alpha belongs to this region, beta belongs to this region. Undoubtedly, I can say alpha less than beta, right. Whereas, f dash x greater than 0 means f dash is increasing function. So, f dash of alpha is less than f dash of beta, right. So, f dash of alpha must be less than f dash of beta, means f of C minus f of A by C minus A is less than f of B minus f of C by B minus C. Am I correct? Now, it is very clear that B minus C is a positive number, C minus A is a positive number, because C is after A and B is after C. So, both are positive. What about f of B minus f of C, is it positive or not? You see, friends, f is increasing function, so f of B is greater than f of C. So, this is also positive, this is also positive. Now, you can align this data like f of C minus f of A by f of B minus f of C. Yeah, Ashila, good evening, how are you? Yeah, this is C minus A by B minus C. Option D is going to be the answer, right. So, this is, I can say here this problem is a combination of Lagrange's mean value theorem as well as bit of monotonicity, right. Fine. Next dear students, you see this is another function. You can say f of x is some function is given where A, B and D are non-zero real constants. Then you see it is clearly f is increasing, decreasing, not a continuous and neither increasing nor decreasing. What you need to do is simply take the derivative of this function and you can see that the derivative of this is completely positive. So, you can comment that f is increasing function. The derivative takes little time to simplify. Simple logic is in this you can apply is the derivative will be going to be positive. Okay. So, it is increasing function. Then friends, you see this question, f of x is going to be a cubic polynomial. Now, this is increasing an or decreasing an or kind of questions. So what you can do is simply you take f dash x, that is the thing what we need to do, right. So this is 3x square minus 6x plus 5. So quadratic expression, we need to see where it is positive. I think you are aware, if you try the factors you won't get, you just apply delta, friends. Delta is going to be b square minus 4ac 60, which is negative. For a quadratic expression, if delta is negative, you know, since x square coefficient is positive, this expression is always positive. That means for all x belongs to R, this expression is positive. So f dash x is always positive means f is increasing for all x belongs to R, right. That is point number A, right, option A. So dear students, yeah. So I mean to say monotonicity is a simple topic where you need to remember only a couple of points. A function is, especially continuous function, differentiable function. Increasing means apply derivative which is to be greater than 0. Decreasing means it must be, derivative must be less than 0. That is all, and we have seen the main important models which are frequently reflecting in JEE Main. Right, dear students, you please practice these questions. All the PYQ you practice, I am damn sure you can attempt the question in JEE Main. Okay. And one more important thing is, we are on Telegram. You see, this is our Telegram channel. Please subscribe to us for daily updates, and we will be giving all the updates related to JEE, NEET and all the other competitive exams even. Right, dear students, that is all. We are from Infinity Learn by Sri Chaitanya. Right, dear students? Yeah. So my next session will be on Thursday 5 o'clock, where we are going to discuss maxima minima related questions. Fine. Until then, thank you. See you. Please subscribe to Infinity Learn. All the best.